Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So I'm going to first start by rewriting 8 as 2 to the power of 3. So I get 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. Now I'm going to rewrite 2 to the power of 3 to the power of x as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 68, and I can do this because if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y to the power of 3 plus y is equal to 68. And now I can subtract 68 on both sides. So I get y to the power of 3 plus y minus 68 is equal to 0. Now, to actually factor this and find the value of y, I need to first find the factors of 68. So the factors of 68 are 1, 2, 4, 34, and 68. So now 1 wouldn't work because 1 times 68, we can't subtract those two to get y. And 2 wouldn't work either. The only one that would work is 4, because if you divide y minus 4 with y to the power of 3 plus y minus 68, that would be factorable. So now that we know that 4 is a proper factor, for my original equation here, y to the power of 3, I'm going to rewrite this as y to the power of 3 minus 4y squared plus 4y squared minus 16y, which is 4 squared, plus 17y, because negative 16y plus 17y is equal to y, and finally minus 68 at the end is equal to 0. Now I'm going to factor by grouping. So these two are a group, these two are a group, and these two are a group. From y to the power of 3 minus 4y squared, I'm going to factor out y squared because that's the greatest common factor. So I get y squared times y minus 4 plus, from 4y squared minus 16y, I'm going to factor out 4y, so I get 4y times y minus 4. And from 17y minus 68, I'm going to factor out 17, so I get 17 times y minus 4 is equal to 0. Now if I factor out y minus 4, I get y minus 4 times y squared plus 4y plus 17 is equal to 0. And now this gives me two equations. I get y minus 4 is equal to 0, and I get y squared plus 4y plus 17 is equal to 0. So for y minus 4 equals 0, add 4 on both sides, and I get y equals 4. For y squared plus 4y plus 17 equals 0. I can factor this by using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a. So in this case, a is 1, b is 4, and c is 17. So I get y is equal to negative 4 plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times 17, all over 2a, so 2 times 1. This is equal to negative 4 plus or minus the square root of 16 minus 68 over 2, which is equal to negative 4 plus or minus the square root of negative 52 over 2. And this is equal to negative 4 plus or minus the square root of 52 times the square root of negative 1 over 2. And the square root of 52, this can be simplified to, well, 52, that's 13 times 4, and 4 is 2 times 2, so this can be 2 root 13. So I get y is equal to negative 4 plus or minus 2 root 13 times the square root of negative 1, which is simply equal to I, over 2. Now if I divide both terms by 2, I get y equals negative 4 plus or minus the square root of 13i. Or sorry, negative 2 plus or minus the square root of 13i. So now that we know these values of y, remember how we let 2 to the power of x equal to y, meaning I get 2 to the power of x equals 4, and this is obvious, x equals 2, so that's one solution of x. And I also get 2 to the power of x is equal to negative 2 plus the square root of 13i, and 2 to the power of x is equal to negative 2 minus the square root of 13i. Well, 2 to the power of x, we can't take the power of a positive number and make it equal a negative number. So there's no solutions for these two, and x equals 2 is my only solution to this problem. Alright, so in this problem, I have 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. So I'm going to first start by rewriting 20 as 19 plus 1. So now I have 2 to the power of 19 plus 1 minus 2 to the power of 19 is equal to 16 to the power of x. Now, if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 2 to the power of 19 plus 1, and this is going to equal 2 to the power of 19 times 2 to the power of 1. Now I have this minus 2 to the power of 19 is equal to 16 to the power of x. Now from here, if I factor out 2 to the power of 19 from my left-hand side, I get 2 to the power of 19 times 2 to the power of 1 minus 1 is equal to 16 to the power of x. And 2 to the power of 1 minus 1, that's simply equal to 1. And anything times 1 is itself. So I have 2 to the power of 19 is equal to 16 to the power of x. Now, 16, that's the same thing as 2 to the power of 4. So now I have 2 to the power of 19 is equal to 2 to the power of 4 to the power of x. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 4 to the power of x, that's going to equal 2 to the power of 4 times x, which is also 2 to the power of 4x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 19 is equal to 4x. Now we have a simple equation here. All I have to do is divide both sides by 4, and I get x is equal to 19 over 4. Now, to check, my original equation was 2 to the power of 20 minus 2 to the power of 19 is equal to 16 to the power of x. Now, 2 to the power of 20 minus 2 to the power of 19, we already know that's 2 to the power of 19. So we get 2 to the power of 19 is equal to 16 to the power of 19 over 4. Now 16, that's the same thing as 2 to the power of 4, so now I have 2 to the power of 4 to the power of 19 over 4, and these two 4's cancel out, so I get 2 to the power of 19 is equal to 2 to the power of 19.